Oh, at this point in the course, you can build a GUI with a diagram window that has inputs and outputs. It has a calculate button, and you can embed graphics objects and control them. So in this video, we're going to show how to deal with plots on the diagram window. Your GUI is meant to display the results of some underlying ease simulation to a user, and often this is done best using a plot. So a plot access button can be placed on the diagram window, and that allows easy access to a particular plot window that updates in response to the results of a calculation. Or you can actually, if you have the professional version, just put the plot itself on the diagram window. So in order to go through this, it's probably best to do this in the context of an example. So let's create a diagram window that is a GUI for a simple simulation of a steam turbine, and then we will use a property plot to show the inlet and outlet states of the turbine on a TS or maybe a TV diagram. So first, as usual, we're going to solve the underlying engineering problem. This one is, I think, pretty simple. So I'm going to set the unit system using a $unit system directive, and then I'm going to set the inputs. So these include the inlet pressure and temperature for the turbine, the exit pressure for the turbine, and the turbine's isentropic efficiency. And you'll see that I'm converting all of these to the base SI unit system and making sure that they're consistent with my unit system that I set with the $unit system directive here. I'm also going to go ahead and set alternate units for these, and that's so that it's easy for me to put them onto the diagram window using units that are a little bit more easy for the user to use. All right, I'm going to put all of these into a $if not diagram window clause, and that just makes sure that they're removed automatically from the equation window when I eventually start running my program from the GUI associated with the diagram window. Okay, I need to get then the inlet properties, so I'm going to do that using the substance information dialog, which I select from the options menu. So I'll go ahead and select real fluids and search for water, and I'm going to pick the fluid water here. And the function that I'm interested in is this real thermal props function. And if I use these two drop-down menus, I know the temperature and the pressure. These are the inputs that fix the state. And then I'm going to do this at the inlet condition, so that's going to be state 1. So square bracket 1, square bracket is going to be what I'm going to append all of these properties. And I'll hit paste. And now this one call will give me all the thermodynamic properties at state 1. I need the enthalpy of the steam that would be leaving an isentropic or a reversible turbine, so I'm going to compute that using the enthalpy function with the exit pressure but the inlet entropy. And then the enthalpy of the steam leaving the actual turbine will be higher than this value based on the turbine efficiency. So finally, one more call to the real thermal props function will complete the program. Again, I'm going to access it from the substance information dialog, and now I'm going to have to indicate that I know not pressure and temperature, but pressure and enthalpy, and the state is now square bracket 2 square bracket. So solving leads to the prediction of basically all the states, all the properties at the exit of the turbine. So for example, the exit temperature. And now I have a turbine simulation that works, so I'm going to then make a GUI for it. So this is something we've done before. Let's go ahead and bring up the diagram window, and we'll create a quick and easy GUI for this simulation. So I'll put it in development mode. I'm going to go ahead and grab just a turbine graphic from the palette here, and I'll paste that in. Again, that's only going to be possible if you have the professional version of ease. I'll add a calculate button. I'm going to set up some inputs. So I'm going to set up inputs for the inlet pressure and temperature, and I'm going to make sure these are in alternate units here, so I can set those in megapascals and Celsius, because that's probably what the user is going to want to do. I'll have inputs for the exit pressure and the turbine efficiency, and then we could output whatever we want. I'm going to output the turbine exit temperature, and again, I'm going to use alternate units, so it'll be showing up here in degrees Celsius. And yeah, if I put the diagram window in application mode, I can hit the calculate button and show that that it works okay. So now we're ready to add a plot. So first I have to create the plot that I want to display. So I'm going to create a plot that shows the inlet and the outlet states of the steam. And at least initially, let's do that on a temperature entropy diagram. So select property plot from the plots menu, and we'll create a property plot for water. And again, TS diagram here, and I'll keep all of these isobars on it. I think I'm going to get rid of the isocores just to make it less busy. And then I'll select overlay plot from the plots menu. And let's see, if I have a TS diagram, S is going to be my x-axis and T is going to be my y-axis. And I want this plot to automatically update. Let's add some point labels. And yeah, now it should automatically adjust to show states 1 and 2 as everything changes. And the last thing maybe is connect these 2 points with a dark red line and use a dark red square. Okay. So that looks good. Now let's return to the diagram window, and we'll put it into development mode so I can adjust it. And I'm going to add a plot using this Add Plot Access button on the toolbar here. And once I do that, I'm going to get this Show Plot Window button dialog. And at the very top, you can select the plot that you want to allow access to, and in this case we only have one, so the drop down menu isn't only going to show us that one. If we had more than one, we'd have to select between them. If you have the professional version of these, you have sort of two choices then. This lower radio button indicates that we're just going to add a button to the diagram window, and when the user clicks the button, then he or she will be taken to the plot window. So let's do that first. We'll click OK. And you can see that right here now we have a plot window access button, and I can bring that up next to the calculate button, and I can move it around or resize it whatever I want. If I go back into application mode now, you can see that if I calculate, so I run my simulation and click this show plot button, it's going to bring the selected plot window all the way to the front of all of the other windows, and it updates its contents. And I can hit this little arrow down here at the lower right corner of the plot window to go back to the diagram window. And if I update the inputs and run the simulation again, you can see that if I go back to my plot window, it's been adjusted for the current simulation. So let's maybe go back, and in this case we'll delete the plot button and add another plot button. So we'll go back to the Add Plot Access button again, and this time because I have the professional version here, you can see that I also have the option of showing the plot in the diagram window. So let's go ahead and click that, and you'll see that then the dialog changes a little bit, and it allows you to control the appearance of the plot. So if we click the OK button, and you can see that the selected plot now appears in the diagram window, and it has these 8 handles that allow me to move it around and resize it however you like. And actually, just like the graphics object that we talked about previously, if I actually name the plot in the dialog, then I can control its appearance and its position using the left and the top and the width and the height characteristics of the named object. So now if I enter the application mode and I click the calculate button, you will see that the updated plot is just redrawn directly in the diagram window, and it reacts basically instantaneously to changes that I make in the inputs. Alright, so one last thing here is if I go ahead and name this plot object, I can actually automatically, programmatically change the plot that's displayed in the diagram window. So let's go ahead and make another plot. So maybe we'll make a TV plot in addition to our TS plot. So again, I'm going to make a TV plot for steam. Once that's done, I'll overlay the states and have them labeled and make sure it auto updates and everything like that. And now I have a second plot, and that's tab 2, whereas the original TS plot I made is now tab 1. So let's go back to the diagram window, and we'll give this plot object a name. So I guess I'll just call it plot. But now the attribute plot tab number can be set to either 1 or 2, and what that's going to do then is actually change the plot that's displayed in the diagram window accordingly. All right. So let's set plot tab number to a variable called tab in the equations window. And then I'm going to add an input for tab so that the user can either enter a 1 or a 2 here. And if he enters a 1, they'll get the TS diagram. If you enter a 2, you're going to get the TV diagram. So we'll go into application mode, and you can see that calculating and then selecting these two 1 or 2 here will actually switch the plot that's shown. And this is a little bit clunky, right? This is not the most sophisticated way to do this. In our next video, we're going to show how we can map strings in a drop-down list to actually a set of ease commands. And that's going to make something like this much easier, much more sophisticated, and really clean up this diagram window.